Dr. Ilara Vance, a cosmologist whose career had been spent meticulously refining the beautiful theory of the cosmos, stared at the data feed from the latest galaxy survey. For decades, the theory had been her sanctuary, a flawless, elegant edifice explaining the universe from its Big Bang genesis to its predicted expansion. Yet, the sanctuary was beginning to crumble. The first hint of trouble wasn't a subtle statistical anomaly, it was a cosmic monster. The image on her screen confirmed a structure so vast it defied the cosmological principle. A filament of galaxies, the Titan Wall, stretching 10 billion light-years. "The universe is supposed to be a uniform soup at that scale," she muttered, tracing the colossal arc with her finger. "This is not soup, it's a cosmic backbone." Then came the notorious Hubble Tension. Her colleague, Dr. Jian Li, an expert in measuring the universe's expansion rate, was frantic. Their two most reliable methods, one using the cosmic microwave background and the other using local stellar distances, were yielding two different speeds. H0 equals 67 and H0 equals 73 kilometers per second per megaparsec. "It's a 1 in a million chance this is a fluke, Ilara," Jian insisted over the comms. "It's not just broken, it's two different universes we're looking at." Ilara felt the familiar anxiety of a theory under siege. It was a crisis, but as the old saying went, in science, crisis meant the machine was healthy, gearing up for its next great leap. The arrival of the James Webb Space Telescope, JWST, was supposed to provide clarity. Instead, it delivered the most shocking anomaly yet, the premature giants. Dr. Ben Carter, the lead analyst for the Deep Field JWST images, burst into Ilara's office. He slammed a sheaf of printouts onto her desk, his face a mixture of awe and disbelief. "Ilara, look at this. These galaxies, they shouldn't exist, not yet." The images showed bright, fully formed, and chemically mature galaxies dating back to just 280 million years after the Big Bang. The beautiful theory mandated a slow, lengthy process of mergers, tiny lumps forming into larger ones over hundreds of millions of years. The timeline whispered, "It's like finding grown-up kids in a kindergarten. They're full of heavy elements, carbon, nitrogen. That means entire generations of stars lived and died before this image was taken. The early universe was in fast forward, or we're missing the entire first chapter of galaxy formation." The sheer audacity of the cosmos was staggering. Structure was too large, expansion was too fast in one measurement, and maturity was too early. The beautiful theory was not just cracking, it was screaming that its story was incomplete. The global cosmology community split into two camps. The refiners argued these were Uranus moments, noise, calibration errors, or simply missing pieces that would ultimately strengthen the existing model, like predicting a dark planet. The radicals, led by Ilara and Jian, saw the chilling echo of Mercury's orbit, a fundamental breakdown requiring a completely new law of physics. Ilara and Jian started working together, focusing on the common thread, the beginning. If the early universe was too fast, mature galaxies, and the local universe was too different, Titan Wall, local hole, what if the cosmological principle was the lie? What if we are sitting on the cake's cherry? Ilara pondered aloud, referencing the old quote. What if our limited view is a cosmic quirk that doesn't tell us the whole story? Jian, analyzing the Hubble tension, proposed a radical thought. The tension is between the early universe measurements, CMB, and the late universe measurements, local stars. What if the dark energy, the force driving expansion, wasn't constant? What if it was far stronger, far earlier, forcing those first galaxies to sprout in fast forward, and then weakening to what we measure today? It was a heretical idea. A changing dark energy would rewrite the universe's past and future. It meant the cosmic constants were anything but. They had to test it. Ilara and Jian developed a computational model incorporating the idea of an early burst dark energy. The results were mesmerizing. The model allowed for matter to clump much faster in the hyper-accelerated infant universe, generating the massive metal-rich galaxies seen by the JWST in record time. As the early burst faded, the model's predicted expansion rate settled into the two different values, depending on whether one was looking at the ancient echo or the present expansion. The tension, while still present, was now framed as the difference between two distinct cosmic epochs, not a simple error. Most importantly, by allowing for non-uniform density at vast scales, a deliberate violation of the cosmological principle in the model's genesis, it naturally produced the Titan wall and the local hole as remnants of the chaotic, high-energy beginning. The data had forced them to step away from the beautiful, uniform, simple universe. The new picture was messy, asymmetric, and profoundly strange, but it worked. Elara presented their findings at the next major conference. The initial silence was broken by furious, excited chatter. It wasn't the neat, tidy solution of a cosmic Neptune. It was a complete overhaul of gravity and expansion, a cosmic Mercury moment. As she looked out at the faces, she realized the old theory was dead and a new cycle was beginning. The universe had screamed that its story was incomplete, and the result was the next revolution in human thought. The cosmos was about to get a lot more interesting.